All right, so now we're going to look at the law of syllogism and the law of detachment. So the law of detachment, and I'm just going to read from the slide before. The law of detachment basically says, if the hypothesis of a true conditional statement is true, then the conclusion is also true. So we want to find out A, is the conditional statement true? And if it is, then we want to find out if the hypothesis is true, then the conclusion has to follow. So this one is it's really easy to overthink, so don't do it. Don't complicate it because it's not complicated. All right, so A says, if two segments have the same length, then they are congruent. So here's our conditional statement. So we want to ask ourselves, is this statement true? If two segments have the same length, then they are congruent. True. Okay? So the law of detachment tells us if we have a conditional statement that this part's true, so if it tells me that two segments have the same length, then I can conclude that they are congruent. Okay, so it says, you know that BC is equal to XY. Using the law of detachment, what statement can we make? Well, if the two segments have the same length, that's what BC equals XY means. That means that BC has to be congruent to XY. All right, now the law of syllogism, think of if you give your mouse a cookie. This is kind of the law of syllogism like a million times over. So the law of syllogism basically says, it's like the transitive property of equality. If A equals B and B equals C, then A has to equal C, so we can cut out that middleman. Okay, so let's look at these two here. Now this is kind of confusing the way they have this written, so I'm just going to rewrite it a little bit different. All I'm going to do is I'm going to switch the order of these. So I'm going to put the bottom one first. So if x is greater than 5, then x squared is greater than 25. Okay, and then I'm going to put the second one. If x squared is greater than 25, then x squared is greater than 20. All right, now if I look at these, if I look at them as a pair, if x is greater than 5, then x squared is greater than 25. So this causes this. And then if x squared is greater than 25, then x squared is greater than 20. So that causes that. Well, notice this is the same. So if this causes this, and this causes this, we can totally cut out the middleman. And we can just go straight to the, let me get a different color. If x is greater than 5, comma, then we can just jump to the final. Like I said, think of if you give your mouse a cookie on this one. All right, this last slide now. This is just to determine, do you understand the difference in inductive and deductive reasoning? Now, remember, inductive means based on patterns or past events, strong evidence, but not actual fact. And then deductive is cold, hard fact. And it's not a matter of if you can prove something deductively, it's the method to which you draw a conclusion. That's what we're looking at here. So if we look at A, it says each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball in the air, it will return to the ground. So take a minute, and I want you to think about that and decide if you think it's inductive or deductive, and then the same thing, do the same thing with part B, and then I'll come back and we'll go over it and we'll go over why. All right, each time Monica kicks the ball up in the air, it returns the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. I guarantee a lot of you here said it's deductive because you're thinking of gravity. Okay, well, she didn't say because of gravity, the ball's going to return to the ground. She said it's going to return to the ground. She used the reasoning that each time she kicks a ball up in the air, it returns to the ground. So this is what's happened in the past. This is a pattern. She kicks the ball up, it comes down. She kicks the ball up, it comes down. She kicks the ball up, it comes down. That's how she's making this reasoning. Therefore, we would say this is inductive reasoning because she came to this conclusion based on patterns or past events. Okay, now B, it says all reptiles are cold-blooded. This is a fact. Parrots are not cold-blooded, and therefore Sue's pet parrot cannot be a reptile. All this is based on the fact that reptiles are cold-blooded. Okay, so this would be deductive reasoning because it's based on